Hey guys, welcome back to Worms Maths Academy. We're just going to run through limits, average rate of change, and continuity quickly, or not quickly, but we're going to go through it. So, first thing, continuity. A function is continuous if you can draw it without taking your pen off the page. So this function, if it continued on left and right, that would be continuous. However, if I have a function where I take my pen off the page, this, just say that's x equals 1, it's not continuous at x equals 1. So that's what continuity is. If you can draw it without taking your pen off the page, even if I had something look like this, went down to like that, that's continuous for all values of x. Okay, now we'll learn more, we'll need that continuity definition later on. The average rate of change is the gradient between 2 points. So the difference between a derivative and an average rate of change. If I said to you, okay, here's a curve, I want the average rate of change between x equals 0 and x equals 3. The average rate of change is the line joining those 2 points. Right, so it's the gradient of that line. Oops. It's the gradient of that line. Rise over run. However, if I said I want the instantaneous gradient, or just the gradient at the point x equals 0, then we're just looking for the gradient there. And that gradient would be 0. The average gradient from 0 to 3 is the gradient of that line, whereas the instantaneous gradient is at the point 0. Now, why would we have average? We want to use things like average speed, average velocity. So you want to work out, like if you traveled from here to Melbourne, if I said to you, what was your speed? Well, your speed would be lots of different things. Whereas if I said to you, what's your average speed? You know that that's your the speed that you're traveling. If you traveled constantly to Melbourne, that's what it would be. So that's why you use average sometimes, average rate of change. Okay, so average rate of change with a rule f of x is 3x squared minus x plus 5 from 1 to 5. So I've got to find f of 5, which is 3 times 5 squared minus 5 plus 5. That's nice because they cancel out. 3 times 5 squared is 3 times 25, which is 75. F of 1 is 3 times 1 squared minus 1 plus 5. 3 times 1 is 3, minus 1 is 2, plus 5 is 7. Now we just apply our rule, average rate of change, is y2, 75, minus y1, over x2, so x2 is 5, minus x1, which is 1. I get 68 on 4, which is 17. So what that means is if I drew this graph, I don't know what it looks like, just say it's a parabola like that, from the point 1, x equals 1, to the point x equals 5, my average gradient, so my average slope, is 17 over 1. That's my rise, that's my run. So as I move across 1, I move up 17, across 1, up 17, etc., etc. That's your average rate of change. Okay, I should show you on your CAS how you can do that. So 3x squared minus x plus 5. 3x squared minus x plus 5. I would just quickly define it. And then divisor line, f of 5 minus f of 1. Oops, I forgot the 1. Over 5 minus 1. And you get 17. Exactly the same on the other CAS as well. Okay, next thing, limits. What is a limit in maths? A limit is a value that the y that a function or the y value approaches as the input value, the x value, approaches some value. So let's have a look. If I had a graph, doesn't matter what the graph is, we'll call it f of x. There's the point 2, and this point here is 4. So the limit as x approaches 2 of f of x is 4. So we're saying, now, with limits, it's got to approach the same value from both sides. So if I had a different graph, like this, let's say there is 3, and then here is a half, and there's the point 1. I'm going to call this f of x. So the limit as x approaches 1 of f of x, actually we should call it something different, g of x. G of x, 1, approaches 1, of g of x. Well, from this side it approaches a half, and from this side it approaches 3. So it's undefined, because you don't know which, is it approaching, like, is it, as I approach 1, it's going to 3 on this side, but it's a half on this side. How can it go to two different things? So the limit is looking at what it comes from both sides. Now, in terms of notation, what you need to do is you need to check both sides. So I say the limit as x approaches 1 from the negative side, i.e. from here. So the limit as x approaches 1 for g of x, that was 3. And the limit as x approaches 1 from the positive side of g of x, well, that equals a half. Because they're different, the limit does not exist. If they were the same, if they approach the same value from both sides, then the limit does exist. So here I've got an example. I've got a quadratic equation. From the left-hand side, as x approaches 2, which you can see it's doing, y approaches 9. As x approaches 2 from the positive side, my y is approaching 9. So in this case, the limit does exist, and the limit is 9. Now, I said the limit only exists if the function approaches the same value from both sides. So, if this side approached 2 and this side approached 2, so that's 2 minus 2 plus. If this approached 3 and this approached 4, well, then that limit wouldn't exist. Okay, so here, if you approach from the left-hand side, if you approach from the right-hand side, if they approach the same value, then the limit exists. If they don't approach the same value, the limit doesn't exist. Okay, so let's have a look. Here, I want to know, as x approaches 3, x squared on x plus 4, so we can just sub the value in. 3 squared on 3 plus 4, which is 9 on 7. So, in your CAS, you can do it as well. The limit, that's in math, in there, oops. So as x approaches 3 of x squared on x plus 4, 9 on 7. Okay, here we're going to get 2 times 2, 2 minus 3 squared. 2 times 2 is 4. Negative 1 squared is 1, so it's 4. This one here, the thing you've got to look out for is if the bottom, when I sub 4 into the bottom, if it equals 0, then it would be undefined. But let's have a look here. I've got x plus 3, x minus 3, 4, sorry. Over, does that factorize? X plus 4, x minus 3, so they cancel. When I put 4 into the top, I get 0, and into the bottom, I get 1. So it's just 0 in this case. This one here, if I sub 0 in, the bottom would equal 0. So either the limit doesn't exist because the bottom equals 0, or we can take out a h on top. So we end up with 5x squared plus 2xh on h. They cancel. Now we can sub in h equals 0, so I get 5x squared plus 2x times 0, which is 5x squared. So the limit does exist, and it's 5x squared. Now I've written another question out here because I wanted to show you, in this case here, if I sub 2 in, the bottom's going to equal 0 and it'll be undefined. However, if we say the limit as x approaches 2, I can take out an x on top, x minus 2, x minus 2, x minus 3. They cancel. Then we can sub in 2. 2 on top, 2 minus 3. I get 2 on negative 1, which is negative 2. Now let's sketch this graph, x squared minus 2x on x minus 2, x minus 3. Actually, let's do it first. So x squared minus 2x, x minus 2, x minus 3. So my limit is negative 2, but you would think that it would be undefined, because when you put 2 into there, it's 0. Okay, oops, go back and grab that graph. So if we go into graph and table, paste it, this one. Okay, so x minus 2, x minus 3. Now, it looks like it's all good. But if we trace, so there's 4.1, 4.3.9, 3.3.1. If we go to the point 2, no, was it 2? I stuffed that up completely. I didn't put any of the graph in. X squared minus 2x, x minus 2, x minus 3. Now, you can see here that this graph itself looks like it's undefined. Well, it's undefined at 3, but if we go analysis trace and we go to the point 2, can you see there it says 2 undefined? So it thinks when you put 2 into this graph, like if I was to sketch that graph, I'll just do it quickly here. It goes like that and like that. And at the point 2, there's an open circle. Right, so at the point 2, there's an open circle because it's undefined at that point. However, the limit exists because from this side and from this side, they both approach exactly the same value, which is negative 2. So even though the function doesn't exist, the limit itself does exist. So this allows us to use mathematics that we wouldn't be able to do otherwise because we can't divide by 0. But in using limits, we're saying, okay, this function isn't defined when x equals 2. However, the limit, or the value that it approaches from both sides, is negative 2. Okay, if I have 4x and h approaches 0, that doesn't even affect the 4x, so it's just 4x. It's always going to be the same. Likewise here, h approaches 0, 3x squared plus 2. Of course, that's just going to be 3x squared plus 2, because h doesn't affect it. This one here, h approaches 2, well, that's going to be x squared plus 4x. If I sub 2 into that, I get x squared plus 4x minus 6. Okay, let P and Q be the points on the curve. X squared minus 3x, at which x equals 4 and 4 plus h. Find the gradient of the gradient of PQ, and hence find the gradient of x equals 4. So, what are we actually trying to do here? We've got x squared minus 3x, which looks like that. Goes through 0, goes through 3. Where's 4? Well, 4 is a point here. And then we've got some other point further on, 4 plus h, which is here. We're trying to find the gradient between those 2 points. So to find the gradient between 2 points, we know that P is the point 4. When we sub 4 into this, we get 4 squared 16 minus 3 times 4, which is 4. Next, we want the other point, Q, which is 4 plus h. Now we've got to expand that out. So we go 4 plus h squared minus 3 times 4 plus h. So that's going to be 16 plus 8h plus h squared minus 12h, minus 12 minus 3h, which is h squared plus 5h plus 4. So h squared plus 5h plus 4. So it says find the gradient of PQ. So we know m is equal to y2 h squared plus 5h plus 4 minus y1, which is 4, over x2, 4 plus h, minus x1, which is 4. So our 4's cancel, our 4's cancel. I end up with h squared plus 5h on h. We can take out h as a common factor. H plus 5 on h. They cancel, so we say m is equal to h plus 5. So that's what our gradient is. It depends on what the value of h is as to how steep our gradient is. If h was 1, so there's 4. If h is 1, I'd have the point 5, and the gradient between those two, I'd sub h as 1 in, and I'd get the gradient itself is equal to 6, the average gradient. However, it then says find the gradient at x equals 4. Now, if we want to find it at x equals 4, what do we need to do? Well, if I've got the gradient between here and here, if I want to find it at exactly x equals 4, we're going to make h go inwards. We're going to make h get smaller and smaller and smaller. So what we can say, if we let h equal 1, we get m is equal to 6, or 1 plus 5. If we let h equal to a half, then we get m is equal to 5 and a half. If we let h equal a quarter, m is equal to 5 and a quarter. 5 and 1 quarter. If we let h equal a tenth, m is 5 and 1/10. So it's getting closer and closer and closer. Let's let h equal 0. If h equals 0, i.e. the distance between that point and that point is 0, we're going to get the exact gradient, which is 5. So, in this case here, if we wanted to find the exact gradient, we can say m is equal to the limit as h approaches 0 of h plus 5, which is 5. So that's our exact gradient at the point 4. We're just letting the difference between those 2 points approach 0. As it approaches 0, my gradient approaches 5. Okay, so here test your understanding. The average rate of change of the function with rule fx equals x squared minus 2x over the interval 1 to a, where a is greater than 1. So the significance is just saying it's to the right of that. So it's got to be to the right, is 8. So if I want to find the average rate of change between 2 points, I need their coordinates. So I've got the point 1. 1 minus 2 is minus 1. And then I've got the point a squared minus 2a. Okay, my gradient is a squared minus 2a, y2, minus 1, over x2 minus x1, and that equals 8. Multiply this across, so we get a squared minus 2a plus 1 is equal to 8a minus 1, a squared minus 8. Because when you multiply that across, a minus 1. Okay, so we get a squared minus 10a plus 9 is equal to 0. A minus 10, a minus 1 is equal to 0. A minus 9, a minus 1 is equal to 0. So a equals 1 or 9. But we know 1 can't be a solution because a has to be greater than 1. So a must equal 9. So if it was the point 1, 9, f of 9 is 81 minus 18, which is 63. F of 1 is negative 1. So m, 63 minus 1 on 9 minus 1. Did I stuff that up? 81 minus 18 is 65. Okay, so I get, no. 8. Oh yeah, no, that was right the first time. 63 minus 1 is 64 on 8, which is 8. So we know that 9 must be correct. Okay, so hopefully you get limits and that. We do cover them more later on, so don't stress too much. But yeah, it's just an intro and to show you why we use limits. We use limits to see what happens as a value approaches another value. And then here we let h approach 0 because we want to see if we've got 2 points, 1 point here and 1 point here. If I want the exact gradient at this point, well, we just let h slowly approach 0. And when it does, we get the gradient between those 2 points that are right next to each other, which gives us what's called our instantaneous gradient.